Television and video in general are so commonplace in our world today that we have long lost sight of the literally quantum leap in human understanding it took to deliver something that we take entirely for granted today. To appreciate that quantum leap, let's start by dialing the clock back to the late 19th century. The idea that humans would someday see at a distance by means of some technological marvel has been around almost as long as humans and technology. Even before radio was perfected, artists in the second half of the 19th century imagined just such a likelihood. They even imagined wall-sized, flat-panel displays like we see everywhere today. But even amid the many marvels of the era, getting where we are today was going to take something more than what was fully understood in the 19th century. The first requirement for sending pictures through the air is to find some means of decomposing an image into its component parts and then converting those elements into a stream of electricity. The earliest attempts to achieve this effect are attributed to a German inventor named Paul Nipkow, who suggested that an electric telescope could employ a rapidly spinning spiral perforated disc. As each perforation spun past the optical image, a sliver of light would pass through the perforation and land on a photocell on the other side, thus converting the variations in the intensity of light into a fluctuating electrical current. That process is reversed in a receiving device, where a flickering lamp behind another spiral perforated disc converts the electrical stream into a pulse of light, relying on the persistence of the human retina to create the illusion of motion just as it does with motion pictures. There's no evidence that Nipkow himself ever built such a device, but his idea became the basis for every attempt to create a television system prior to 1927. The reality was more like this. This is the inner workings of the first really successful mechanical television system. It was developed by a Scotsman named John Logie Baird, who managed to transmit moving images by radio as early as 1926. We'll come back to Baird presently. Other similar experiments from the era include machines built by Charles Francis Jenkins, who had earned a string of patents developing motion picture camera and projector systems. Here you see a contraption that merges motion pictures with the spinning disc idea that Nipkow introduced. I'm sure many great evenings could have been had lounging on the sofa and watching Game of Thrones with just such a system. But my personal favorite of these television jalopies is this one, a system developed by Herbert Ives for AT&T, which then Secretary of Commerce Herbert Hoover used to transmit a moving image from New York to Washington, D.C. in 1928. See the headline? Television, now reality. But this is what was behind the curtain. A panel full of individual bulbs and a harness of wires connecting each bulb to the spinning disc at its center. This is John Logie Baird again, seen here operating the contraption you saw in the earlier slide. If you ask somebody from Britain who invented television, they will tell you it was John Logie Baird. But Baird didn't invent television as we understand it. He invented a precursor to television, just the sort of machine that clearly demonstrated what would never work. The proof is easy enough to see, because this is as good as mechanical television ever got.
Then, in the late 1920s, scientists across the globe, including Scottish inventor John Logie Baird, finally developed a technique to send moving pictures through the air. As they said at the time, "We have lit a candle that will never go out." That light still burns today, and it is shining ever brighter.
If that light is shining ever brighter today, it is not because of that technology or anything that John Logie Baird ever invented. That Baird was actually able to sell more than a handful of these contraptions is less a testament to the viability of the technology than it is to the public's demand for it. All these clowns who were messing with mechanical television were raised on the classical physics of Newton and Maxwell, building 19th century solutions to what was clearly a 20th century problem. A satisfactory approach to television was no more likely to emerge from these experiments than the electric light evolved out of experiments with candles. The velocities required to produce a satisfactory television image was going to take something completely new. And that new thing began with an obscure patent clerk in Switzerland in the year 1905. Over the course of that year, Albert Einstein published 4 papers that would alter the course of human understanding for the next century. The result of this output represents such a revolution that it is worth the minute it takes to name them all. In his first 1905 paper, Einstein proposed that light could be thought of as a stream of particles, or photons, rather than a continuous wave. In his second 1905 treatise, Einstein introduced the theory of special relativity. The third paper basically proved the existence of atoms. And finally, Einstein proposed that energy is conveyed in discrete units, or quanta, rather than being continuous. This is the fundamental principle of what we now know as quantum mechanics. It was not until 2 years later that he added a codicil to special relativity that introduced the most famous equation of the 20th century. This is the cosmological soup that laid the foundations for all the technological breakthroughs of the 20th century, including television. Now, if I asked you to name which of these momentous discoveries earned Einstein the Nobel Prize, you would probably think number 2, special relativity, or number 5, E equals mc squared, because these are the things for which Einstein is most remembered. You'd be wrong. It was his first paper, published in March 1905, for which Einstein was awarded the Nobel Prize in 1921. In this paper, Einstein articulated and quantified the photoelectric effect, the process by which light becomes electricity when it is shined on certain metallic surfaces. This is the theoretical breakthrough that made real television possible, and it's significant that these ideas were introduced in 1905, because a year later, in August of 1906, a boy named Philo T. Farnsworth arrived on the planet. And while he was born in a crude log cabin in Beaver Creek, Utah, he entered a world that had never not known relativity and quantum mechanics, an accident of fate that uniquely prepared him when he announced to his father some years later that he hoped he had been born an inventor. By the time Philo Farnsworth reached his teens, the idea of television was practically a given. It seemed only a matter of time before motion pictures would be merged with radio and moving pictures would magically fly through the air. The more he read about the early experiments I've just showed you, the more he knew their mechanical underpinnings doomed their viability. And he knew instinctively that bringing the discoveries of Einstein and his brethren to bear on the problem would be a great way to launch his own career as an inventor. From the magazines and journals, he learned all he could about the electron, magnetic deflection, and cathode ray tubes. Accounts vary. The family told me it was probably a sugar beet field, but we're in Idaho now, so everybody thinks potatoes. Whatever the crop, picture a teenage boy sweating behind the business end of a couple of horses, thinking he wants to be an inventor, and that television would be a good thing to invent to launch his career. He has been thinking about it all summer, until one sun-baked afternoon when he turned around to look at the field he had been plowing. And in a moment of what can only be regarded as divine inspiration, he sees how he can scan an image one line at a time with a magnetically deflected beam of electrons and take the idea of television out of the mechanical realm of the 19th century and into the 20th century realm of pure quantum mechanics. Now it's about 6 months later, late winter or early spring 1922. 14-year-old Farnsworth is only a freshman at his high school in Rigby, Idaho, but he has talked his way into a senior science class when one day the teacher comes into the classroom and finds his young prodigy standing in front of something he has drawn on the blackboard, declaring, "This is my idea for electronic television." "Television?" the teacher replies. "What's that?" Now it's 1926, and still nobody has come up with what Farnsworth has had locked in his brain for 5 years since that moment in the sugar beet field. While working as a clerk on a community chest campaign in Salt Lake City, he meets two West Coast financiers, George Everson and Les Gorrell. After listening to the 19-year-old Farnsworth's ideas, Everson and Gorrell stake him to a $5,000 seed fund for what Everson calls as wild a gamble as I can imagine. With some additional funding from the Crocker Bank, Farnsworth, his new wife Pam, and her brother Cliff Gardner set up a laboratory in a loft at 202 Green Street in San Francisco. With Cliff assuming the role of chief glassblower, they started fabricating the revolutionary camera tube that Farnsworth has called the Image Dissector. After a year of experimentation, the first crude attempts evolved into an instrument worthy of the finest practitioners of the art. I should emphasize here that we're focused on the camera and transmitter because this was the missing piece of the puzzle. Once you have a device capable of rendering a high resolution, reproducing the image on the receiving end is the easy part. Farnsworth's first receiver tubes were actually fashioned from a common Erlenmeyer flask and eventually evolved into the sort of cathode ray tube receiver that was the principal display for all video for more than 50 years. After more than a year of experimentation at 202 Green Street, the system was ready to prove its worth on September 7, 1927.
With a single line of light being beamed into an electronic dissecting tube, and from another tube, a cathode ray tube, the simple image, the straight line, being easily reproduced. The world's first all-electronic transmission of television.
Or, as Les Gorrell said in a telegram sent to George Everson, the damn thing worked. This is the informal, extemporaneous language that announces the arrival of video on the planet. Farnsworth simply wrote in his journal, "The received line picture was evident this time." Now, let's take a look at the formal language that defines this event. While all this is happening in the loft at 202 Green Street, the U.S. Patent Office was considering the application for a patent that Farnsworth filed in January of 1927, about 9 months before the first pictures were produced. This patent was finally awarded on August 26, 1930. This patent is the cornerstone of television as it came to be known after World War II, and here is the critical language. This language, Claim 15 in patent number 1773980, formally announces the arrival of electronic video on Earth. This one sentence, these 48 words, written in 1927, is the inflection point that makes obsolete everything that came before it, including those whirligig contraptions we saw earlier, and makes possible everything that came after it, including the screen you are looking at now. It is an eloquent expression of the confluence between what Albert Einstein described in 1905 and what Philo Farnsworth drew for his high school science teacher in 1922. Let's read it out loud. We're talking about an apparatus for forming an electrical image and means for scanning each elementary area of the electrical image and means for producing a train of electrical energy in accordance with the intensity of the elementary area of the electrical image being scanned. This is a precise articulation of the idea that Farnsworth first thought of in 1921 that remarkably nobody else had thought of for another 6 years. By now, I'm sure you must be asking yourselves, if this is such a big deal, why are we just hearing about it now? And the answer to that question is this guy. Oh, no, I'm sorry. I mean this guy. David Sarnoff became president of the Radio Corporation of America in 1930. RCA was formed after World War I to pursue a simple business model. The Radio Corporation was formed to collect patent royalties, not to pay them. As his first mission as president, Sarnoff was determined to extend RCA's domination in radio to the new medium that was likely to take its place, television. Over the next decade, Sarnoff and RCA spent millions of dollars just to avoid paying royalties to Philo Farnsworth for the use of his patents. But as late as 1929, RCA was still experimenting with this mechanical system. There's no footage, only this screenshot of a Felix the Cat doll that was placed on a rotating turntable in front of a spinning disc camera. You can see clearly the arched scan lines, which are the telltale artifact of a spinning disc apparatus. RCA didn't get a handle on electronic television until nearly 3 years after Philo Farnsworth first demonstrated it, and then only after Sarnoff sent this guy to visit Farnsworth in San Francisco. There's not enough time here to go into the details. Suffice it to say that Sarnoff fought Farnsworth on behalf of Vladimir Zworykin's patents throughout the 1930s, not only spending millions of dollars to get around Farnsworth's patents technically, but spending more millions on litigation to get control of those patents. All you need to know for now is that when Zworykin was handed a freshly made image dissector tube, everybody present heard him say, "This is a beautiful instrument. I wish I'd invented it." 4 years later, he would claim that he had. On April 24, 1934, the U.S. Patent Office heard final arguments in patent interference case number 64027. And right there on the front page is the aforementioned Claim 15. It is absolutely impossible to make an electronic television signal without employing the principles embodied in this language. RCA knew this, and in this litigation tried to convince the Patent Office that an application that Zworykin had filed in 1923 predated Farnsworth's 1927 application bearing this language. But the Patent Office was having none of it. In its final decision, rendered on January 22, 1935, the Patent Office declared priority of invention and the ownership of the indispensable Claim 15 was awarded to Philo T. Farnsworth. That should have ended it once and for all. With that decision, the name of Philo Farnsworth should have found a place in the pantheon alongside Edison and Tesla and Einstein and Oppenheimer. But the litigation went on for another 5 years before RCA finally capitulated and accepted the first license in its history, compelling RCA to pay for the use of somebody else's patents. After agreeing to pay Farnsworth upwards of $1 million, Sarnoff was finally free to introduce television at the 1939 New York World's Fair, and RCA began selling television receivers to an eager audience shortly thereafter. This is where Sarnoff also introduced the revisionist history that RCA alone brought television to the world. And where is Philo Farnsworth while all this is happening? By 1939, Farnsworth was burned out. From a decade of long hours in his laboratory, from years of litigation with RCA, and from fighting with his own investors to maintain multiple fronts in his underfunded battle to bring television to fruition in the world. By the time RCA begins paying for the use of his patents, Farnsworth has retreated to a farm in Maine, where he essentially sat out World War II. Philo Farnsworth was arguably the most prominent scientist of the era who was not involved in the Manhattan Project. When invited, he simply said he wanted nothing to do with building an atomic bomb. Instead, Farnsworth started to look for new things that he could develop out of the unique insight into quantum mechanics he had gained over a decade of perfecting television. In the years following Trinity, Hiroshima, and Nagasaki, Farnsworth combined the very best of Einstein's theories with a phenomenon he observed in an advanced amplifier tube he invented in the 1930s. In the late 1950s, Farnsworth started cooking up an invention with the potential to change the world even more than television. Something that even the assembled geniuses at Los Alamos could scarcely imagine: a compact, controlled nuclear fusion reactor. The still unfulfilled promise of fusion, a clean, safe, and virtually inexhaustible source of energy from the same process that drives our sun and all the stars, persists to this day. Farnsworth was building his star in a jar in the 1950s and 60s, but the work remains unfinished, and the family is certain that he took the secret to his grave. All that remains are his patents, which his son assured me are incomplete, and a mysterious personal journal we recently found hidden in the family archives. Several pages of this journal have been torn out, and on the page that follows, his wife has written in her own hand his last ideas he considered too confidential to leave a record of. He felt the world of humanity was not ready for his last gift, and maybe not worthy of it. So while we ponder the mysteries surrounding his second big idea, let's take one more look at Philo Farnsworth's first big idea that changed the world. There's no question that the technology has evolved in the nearly 100 years since this frail image proved that visual intelligence could be transmitted from the bottom of one bottle to the bottom of another. In that century, we've gone from fuzzy cathode ray tubes to ultra-high definition, wall-sized, flat-panel digital displays that show every fiber of flesh, every bead of sweat, and every drop of blood. Now, I hope I have managed to convey that what you see here, both this recreation of that very first image and the high-resolution display you are seeing it on now, could only emerge from the cosmological environment introduced at the turn of the last century, from the brains of Albert Einstein and the hands of Philo T. Farnsworth. David Sarnoff and his ilk would like us to believe that television was too complicated to have been invented by a single individual. But this sketch shows us just how untrue that is, and how really simple the basic idea is if you come at it from the right cosmic angle. This sketch recalls a bold step in human evolution. In its day, this was an epic breakthrough in what humans could do with quantum particles and forces, and reminds us of the unbridled genius that is reawakened every time we plant ourselves on a sofa or reach into our pocket or purse. As we come to the end of the summer of Oppenheimer, who turned Einstein's quantum dreams into an instrument of mass destruction, perhaps it's time we turn a little attention to the forgotten man who turned the same fundamental forces into all of our living room dreams. Thank you for attending my TED Talk.